Okay, our next unit is Chapter 12, and it's an exciting unit. Chapter 12, Stoichiometry. Stoichiometry, exciting word, exciting unit. Gets into kind of how things get together. If you look at the definition, it's the calculation of quantitative relationships, amounts, quantity, quantitative relationships of the reactants and products in a chemical reaction. So, pretty crazy word. We're going to describe it here as I go through, but chapter 12 is stoichiometry. And again, as it says right there, it's a fancy word, but it's a simple concept. Stoichiometry is defined as that portion of chemistry dealing with numerical relationships, quantitative, in chemical reactions and the calculation of quantities of substances involved in chemical reactions. It sounds fancy, but it's a simple concept. I'm sure you use stoichiometry and use it all the time without even realizing it. I got an example. This is a little holla at my balas. If you're in my class, you know that I'm a basketball coach, been a basketball coach for a long time, and my basketball team. Let's say I have 11 girls on my team. This year I have 13, so be it. But to make one lineup or one group of girls on the court, I need one center, two forwards, let's say, one shooting guard and one point guard. Obviously, there's differentiation. This year I have probably 4 guards and maybe a forward on my team. But let's say one center, one forward, one shooting guard, and one point guard. And again, the point being it's a 1 to 2 to 1 to 1 ratio in essence. Okay, so that's the quantity, 1 to 2 to 1 to 1. All right. Now, if I want to make, or I guess the question is, how many possible lineups could I make with this being the ratio, 1 to 2 to 1 to 1? Well, if I have 11 girls, and again, not counting if they played in different lines, if I have 11 girls, there would only be 2 because I need 5, 1 center, 2 forwards, 1 shooting guard, 1 point guard to make one lineup. I only have 11 girls, so therefore I could only make 2. Even though I have 13 girls this year, I still could only make 2 because I need 5 different girls. So that's kind of the idea there. All right. Here's a picture. Well, that was the team in 09-10. I put another one up there. There we are in 10 and 11. And I think that was also that same year, kind of when we did our pink game, breast cancer awareness and fundraiser. Well, there's us winning a big game in the tournament up in Augusta. All right, let's move on. Oh, nope, that's last year's team. I don't have this year's team's picture yet, so we won't put it up yet. Again, it's a fancy word, simple concept, defined as dealing with numerical relationships in chemical reactions and the calculation of quantities. So again, another example. If I want to make cookies for the class and I have 76 total students, a normal batch of dough makes 24 cookies. How many batches would I have to make? Well, again, we can kind of think of it. If there's 24 cookies in a batch, if I multiply that by 3, let's say, that gets me to 1272. That's not going to be enough, so I don't have enough. If I make 3 batches, I'd have to make 4 batches. I'd have to make 4 batches to get enough cookies for 76 students. Obviously, I'd have tons extra. People could have more. So that's stoichiometry, dealing with the quantities. Additionally, all these kind of ingredients and how much there are is certainly another piece of stoichiometry. The amount. If I put 2 1/4 cups of flour, 1 teaspoon baking soda, 1, etc., 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 the amounts, that becomes my ratio, that becomes my quantity, that becomes the stoichiometry that I need to make a delicious batch of chocolate chip cookies. So there you are. Oh, I put a few pictures here. I was kind of in the mood to kind of throw a few pictures. Here's a couple of the daughters. A long time ago, I'd say this is probably 4 years ago. The 2 girls. Yeah, they were doing some cooking in the living room. They love to cook. Oh, there's Quinn, very young, probably a little over 1, with some lobster, getting ready for that. Oh, Aaron, again, real young, grating some Parmesan for some crust. Oh, there they are again. Cuties cooking with their dad. Oh, that's a croquembouche I made one Christmas. I love to cook croquembouche. Just basically cream puffs. Cream puffs, homemade. Oh, there they are cooking again, cutting up some apples for, I don't know what kind of apple dessert I was making there. Licking the bowl. This is a little bit more recent. How about that guy? All right. So again, fancy word, simple concept. I've got to make sure. I mean, it'd be terrible for my youngest one if I don't show a picture. The girls are a little bit older now. Here's now 3 of them with the new one, and this is a small photo. That's them at Halloween. Here's the new one. So this is youngest daughter. Cutie, right? Cutie. All right, so we go back to this. Lastly, I don't want to spend a lot of time on another example, but you know, an orchestra, a symphonic orchestra, obviously the amounts of the pianists and the violinists and the percussion and cello and et cetera, all stoichiometry. Simple concept, portion of chemistry dealing with numerical relationships in chemical reactions and the calculation of quantities of substances involved in chemical reactions. So I guess we're going to kind of leave it right there as I move on to the next slide, next video.